All right, ladies and gentlemen, greetings from my basement. This is Mr. Briggs with Stretching and Shrinking 1.3. This is the first lesson in our new unit, and this lesson is all about scaling things up and scaling things down, basically enlarging things or shrinking things. If you've ever hit expand on a photocopier or made a tiny photo into a big photo or a big photo into a tiny photo, you kind of know what we're talking about here. Our lesson today is going to take place on page 10 and 11, problems A through E. Now, these are mostly written questions. There's not a whole lot of math, but you'll still need to think about it. I want complete answers. And then we'll have to do ACE problems 5 through 12, 14 through 19, 20 through 22, and then skip ahead to 24. Why so many? Well, because this is the only lesson we're doing in this particular investigation, and we want to make sure you get lots of practice so that you will be adequately prepared for the upcoming lessons. All right. Your learning target for today is that you can identify corresponding sides and angles. Okay, let's go ahead and get started. First, we're going to get our notes ready. We're on page 10 and 11 in our book. It is lesson 1.3 notes, and it is in our new unit, Stretching and Shrinking, which is why I've got the S and S. And we're going to want to make sure we have the name, date, and crew on this page as well. Now, the very first thing we're going to talk about, the very first heading, is similarity. Let's see if I can do that better. Similarity and correspondence. And similar figures is our very first vocab word for this. Now, similarity and correspondence is our theme, and the first thing we're going to talk about is similar figures. And figures are considered similar when they share the same shape but are not the same size. So they're either larger versions or smaller versions of each other. For instance, if I have a Matchbox car and a real car, if I have an action figure and a real person, if I have a model plane and a real plane, if I have a person and a statue of that person many times larger, this would all be examples of similar figures. And here I have my example. I have these two similar triangles. Notice how their angles are the same. Notice how the lengths increase or decrease at the same rate. So those two things need to be there in order to be similar. They need to have same angles and grow or shrink at a constant rate. Okay, we'll learn more about what that is later. Okay, you just need to have this down. Pause it if you need to before we move on. All right, our next one is notes, part 2. And the next thing we're going to talk about is correspondence. Now, there's the kind of correspondence which means writing letters, and then there's the correspondence in math. And correspondence in math basically means how do things relate to one another. Okay, and correspondence is considered the part of similar figures that match. For instance, if I have a man and a child, they both have right hands. They both have a head. They both have two eyes and a nose. They both have parts in roughly the same place. They're just a smaller or larger version of each other, depending on your point of view. Or if I have a Matchbox car and a real car, they both have wheels. Their wheels correspond to each other. Okay, they relate to each other. I could say there is the front passenger side wheel of the Matchbox car. Here is the front passenger wheel of the real car. I can point to one and know exactly where to look on the other. And there are two kinds of corresponding features that we talk about with polygons. One is corresponding angles, and that's that two angles that match in similar figures, and corresponding sides. And that's two sides in a figure that match. Two sides in let's fix that, figures that match. Sorry for that mistake. And here I've got my example. You'll notice that this longer side corresponds with that longer side. They increased or decreased at the same rate. Okay? And these angles correspond. I know that that skinny angle matches that skinny angle. Okay? Basically, if I point to one, I should be able to point to the other very easily. And correspondence basically just means how does one relate to the other. Okay? Moving on. Notes part 3. Now this part's a little tricky. For this one, we're going to be reviewing a couple of things for your homework. One is finding the circumference of a circle. And the circumference of a circle basically means we take the diameter and multiply by pi. Now, pi, despite being delicious, is also a number, and it starts with 3.14, and it goes on forever, and I bet one of you is going to try to repeat it, how many digits for me, but I'm going to use 3.14. And how does this work? Well, let's say my circumference here, or not my circumference, my diameter here equals 2 inches. I want to know what my circumference is. Well, how do I solve that? I take 3.14 and I multiply by 2. I get 8, I get 2, and I get 6. So I should get a circumference of about 6.28. And I'm sure one of you kids is going to tell me, well, Mr. Briggs, it's really 6.131653. Okay, I rounded, okay? 6.28, about 6.3 is going to be the circumference. Okay, then the next thing we're going to do is finding the percent of a number. What is 15% of $30? Well, there's a lot of mental math I can do, but a really quick way is to just take 30 times 0.15. And 0.15 is just the decimal form of 15%. And if I multiply that out using a calculator... Alright, ladies and gentlemen, so when we take 30 times the decimal version of 15%, we end up getting 0.15 as the decimal form. 30 times 0.15 gives us 4.5, which makes sense to us if we think that 10% of 30 would be 3, and then half of 3 is 1.5. So 15% being 10 and 10% and half 10%, I could go on and on. But we end up getting 4.5%, and that is a reasonable answer. Our coursework today is going to be on pages 10 and 11 in your book. We want to do lesson 1.3, practice for stretching and shrinking. Make sure we have name, date, and crew on this fresh sheet of paper. Your lesson starts on page 10, goes to 11. It's going to be problems A through E. You may need a ruler to solve some of these problems, or it might be handy at least. Then our ACE problems are going to be 5 through 12, 14 through 22, and then 24. All right, ladies and gentlemen, have fun, have a good time, do some good work.